Today we're going to be working on a pair of 6X Pontiac heads, and these heads also have the additional ID stamping of 8, which indicates anywhere in the range of 1975 to 1978 400 cubic inch motors. We're going to be doing a full valve job and resurfacing all of the gasket surfaces on these heads, but in this video we're going to just focus on the guides and the seats and the broken stud. To get things started, I'm taking a quick length measurement of the heads and adjusting the rollover fixture on our TCM25 valve seat and guide machine so that we can get the head in the machine to start on the valve guides, which are worn out. This fixture allows us to get everything from your EJ25 Subaru heads and smaller up to some of your 6-cylinder John Deere heads mounted to the rollover fixture, which makes it super nice to be able to roll over the head and work on both the top side of the head with the guides and the bottom side of the head with the seats. With the head bolted to the fixture, I'm using one of our tapered Sioux valve guide pilots that fits these guides and a level. With the machine having been set up perfectly level, we must also set up our cylinder head to be perfectly level in the fixture in order to drill out the valve guides. Making our rough adjustments to the level by rolling the fixture before locking it down, and then using the fine adjustments on the table to bring our head as level as possible. In theory, with the design of this type of head, every single valve guide is going to be at the same exact angle. That being said, we're going to double check by checking the level on 2 different valve guides across the head and kind of setting an average before locking down the table. The guides on these heads were simply drilled from the original casting of the head, so for our replacement guides, we have to use one of our piloted core drill reamers. The pilot at the bottom of this tool is made for the ID of the valve guide, so that we can get centered up on the guide, while the top portion of the tool is a drill and reamer combo that brings the diameter of our hole to 1/2 inch for our replacement valve guides. We typically use hardened cast iron valve guides for a replacement, which in a situation like this have roughly a 2/1000 interference fit. When installing the new guides, it's critical to use some form of lubrication like a good press fit lube, or else the guide will gall and the install will be a failure. The guides are installed flush with the casting on the combustion chamber side in this case, and next we're going to be using our diamond valve guide hone to fit them to the specified valve stem clearance as per the OEM specification. We're also choosing a SerDes pilot that fits well so that when we do our machine work on the valve seats, we don't have any chatter or anything like that, as well as checking to see that the guide is straight all the way through using our bore gauge. As you can see, the replacement guides are a bit long, and we'd also like to machine the top of the valve guide so that we can install positive valve stem seals, which are a bit of an upgrade to help meter the oiling of the valve guide and valve stem, but we must create additional clearance on the top of the guide to make room for this seal. We're also using 2 spring shims that amount to 75 thousandths of an inch as a gauge for how far to cut, as we want to leave this amount to keep the original guide diameter at the bottom as the locator for the valve springs. With all the machine work on the valve guides finished, we're about ready to move over to the SerDes. But before we do that, I wanted to take this broken exhaust manifold bolt out. So basically, I just take a nut and a washer, weld it to the broken bolt. I went ahead and checked to see if it was moving before I went and got some candle wax and let the candle wax melt and go into there. Personally, I think penetrating oil works better, but I don't have any right now, so I had to use the candle wax. But it did come right out, so maybe I'm wrong. Now we're heading over to the SerDes to get started on the valve seat work, and since I'm only doing the seat work, I don't really need the rollover fixture, but it was already on the machine, so I figured why not go ahead and use it, even though I don't need to be rolling over from the valve guide side to the valve seat side. Leveling up on the SerDes is quite a bit different than on the TCM25. On the SerDes, you stick a pilot in, we have this little bubble level, and that gets it close, and any misalignment in any of the valve guides is going to be compensated for by the patented 3-flow air system that the SerDes head has. We're going to start here by cutting the counterbores for our exhaust valve seats. So what I'll do is touch the cutter down to the head, and I'll maybe move up about 5 thousandths, and then we'll use the thickness of our valve seat to set the stop on the spindle so that we have a positive stop to come down against when we're cutting our valve seat counterbore. With the valve seat counterbores cut, I'm going to grab my brand new BFH from my new MichaelPro Tools fully loaded tool cabinet, which I'm extremely excited about because I finally have my own full set of tools instead of scavenging from the tools that my dad has collected over the last 40 years of being in business. Getting our driver set up here to drive in the valve seats. Again, they are an interference fit, and I get a lot of people asking, why don't you cool them off? Why don't you use liquid nitrogen? It's just not something that's really necessary. It's not like they're tough to get in. You just get the driver out, drive them in, and call it a day. With the valve seats driven in, you're going to notice a couple of things here. First thing being that the ID of the valve seat we're using is actually a bit small and doesn't match the casting super well. So the first operation we're going to do here is to go in with a cutter on the ID of the seat, and I'm going to open it up to where we just perfectly match the diameter of the throat of the port. Next thing you're going to notice is I mentioned earlier that before cutting the counterbore, I brought the cutter up maybe 5 thousandths, and that's because I would rather leave my seat slightly high and have to trim it off than to leave it too deep. So we're going to take a 90-degree cutter and come back in and trim that last few thousandths off the top of the seats until they're just flush with the machined combustion chamber surface of the cylinder head, exactly the way they would have looked from the factory. At this point, we're ready to start our valve seat machining on the intake seats, and I don't know why Pontiac uses such a big valve with such a constricted port design, and I'm sure these heads could benefit from support work, but in this case, it's just a stock rebuild, so I'm only going to do what I need to do to get a quality seat machined, because the customer's not willing to pay for all of the extra performance modifications. To start, we're going in with a straight 65-degree cutter and opening up the throat area a bit to make it so that when I come in with my 3-angle cutter, I'm not going to be cutting the full cutter width because at roughly 2-inch diameter, the full width of the cutter makes for a very strong cut and it's very likely to chatter. You'll see here now that I can run a much faster RPM on this lighter cut with the 3-angle cutter, and first our 60-degree bottom angle comes in, followed by the 30-degree seat angle, and then the shallow upper angle that comes in last. I also tried something new here with having the mister lightly spraying a constant stream of coolant onto the seat, which I've mentioned in the past videos can sometimes help aid in cutting. Now you've probably noticed that the first 65-degree cut we did left a nasty edge at the bottom of the cutter, and again, we're not trying to do anything performance here, but obviously that's not what we want, so I've adjusted the cutter to a smaller diameter, and then we're coming back in again to simply smooth that out and make a nicer transition from the port into the bottom seat angle. Now at this point, cutting the exhaust seats is literally like cutting a piece of cake. We have a 60 thousandths wide 45-degree cutter with a 30-degree top angle and a 60-degree bottom angle. From the factory, these heads have virtually no top or bottom angle on the exhaust seat, and that's how they're going to look when we're done here as well. You're simply going to see a sliver of the bottom angle and a sliver of the top angle so that we know we have our full seat width, and that puts our seat exactly on the valve where we want it and gets our depth perfect as well. Again, I'm sure these heads could benefit from some additional work in the ports down the road if someone really wanted to pay the additional money to try and squeeze more performance out of them, but in this case the goal was simply a stock valve job to make them new again. From here they're going to be resurfaced and assembled with new stock replacement parts. We hope you all enjoyed this video. Don't forget to like and subscribe, and shop gmzonline.com to support more future videos. We'll see you in the next one.